Welcome to BVS Pragati channel. In this session, let's have a look at the pin diagram of 8086 microprocessor. So the 8086 microprocessor has 40 pins, and the main salient features of 8086 microprocessor is that it has 20-bit address bus, that is, it is capable of addressing 1 MB of memory, and it has 16-bit data bus. 8086 microprocessor, it operates in two modes, min mode and maximum mode. So you have min line and max line, okay, mn by mx bar. So if processor along with memory IO device is connected with the system bus, it is minimum mode, and if multiple processors along with memory IO devices is connected with system bus, then it is maximum mode. So what decides that? So this is pin 33, min slash mx bar. This decides whether it operates in min mode or max mode. So in the max mode, these values these pins take these values. And in the minimum mode, it acts like these values. Okay. It acts like these values. So when mn by mx bar goes 0, then when it is connected to ground, that is when it is in max mode. And when mn by mx bar is high, when it is connected to VCC, that is 5 volts, then it acts in minimum mode. So what is the value of VCC? VCC is 5 volts. So to turn on the microprocessor, you need to apply 5 volts over here. 40 pin is the VCC pin, and you have two ground pins, that is 1 and 20. And as we have discussed, there are 20 address lines: AD0 to AD14, AD15, A16, 17, 18, 19. So you see AD is address data. So when you say that, that means that address and data are multiplexed together. And when here address and status signals are multiplexed together, from A16 to A19, address and status are multiplexed together. Okay, so we have now finished one up to this pins and AD15 also. Okay, so A16, A17, A18, A19. Okay, now what is NMI? There's one more pin that is left over here, NMI, that is non-maskable interrupt. So normally there are two types of interrupt, maskable and non-maskable. If the interrupt is controllable by programmer, it is maskable interrupt. If the interrupt is not controllable by the programmer, it is non-maskable interrupt, that is NMI. What is INTR? It is interrupt request. Okay, and clock. So all the signals are synchronized with respect to this clock frequency. Now you have A16 and A17. Okay, A16 by S3, A17 by S4. So when S3 and S4 take on different values, then it means different conditions. So when S3 and S4 is 0, 0, that means that it informs the processor which segment is to be accessed. So when it is 0, 0, it accesses extra segment, and when it is 0, 1, it accesses stack segment. When it is 1, 0, it accesses code segment, and when it is 1, 1, it accesses a data segment. And you have S5 and S6. S5, this is interrupt flag, IF is 0 or 1. And what is S6? It is status flag, and it holds logic value 0, and it is used for future purposes. There is this BHE bar by 7. Again, BHE is bus high enable. So when this and S7 take on different values, it means different things. So when this is 0, 0, it means that the processor accesses 16-bit data. processor accesses 16-bit data. And when it is 1 1, when it is 0 1, it accesses upper part of data is stored in odd band. Lower part of data is stored in even band. It is idle, processor does nothing. So when BHE is 7 take on different values, when it is 0 0, what happens? Processor accesses 16-bit data. And what is the pin? The pin is 34. Okay, 34 is the pin. And when BHE and S7 takes different values, it means different things. When it is 0 0, processor accesses 16-bit data. When it is 0 1, the upper part of data is stored in odd band. When it is 1 0, lower part of data is stored in even band. Okay, and when it is 1 1, it is idle and processor does nothing. Okay, this is all about BHE S7. Now let's have a look at other conditions. So what is RD? This pin number 32, that is read bar. So when read bar is 0, the microprocessor reads the data. And when read bar is 1, the microprocessor does not read data. Okay, this is all about read bar and it is pin 32. This test bar, okay, 23. So test pin works on wait instruction, and when it receives wait instruction, it starts testing. And there's also ready. What does ready do? Ready is pin number 22. And what does it do? External devices or peripherals, when it is high, it takes instruction from external devices or peripherals. Reset, it is used to reset to the default value. Hold, this hold value. So this is the max mode. So if you see in the max mode, the address and the data lines act similarly whether it is in max mode or min mode. But the pins 24 to 31 take on different values at different instances. When it is max mode, it takes certain values, and when it is min mode, it takes certain values. So when it is max mode, it takes these values. When it is min mode, it takes these values. Let's have a look at the min mode values. What is hold? When it receives, hold indicates that another master has been requesting a local bus. So when it goes high, the microprocessor receiving hold request will issue hold acknowledgement, that is HLDA goes high. Write bar. When it goes to 1, when it goes to 0, the processor writes the data into memory or output device depending on status of M/IO bar. So what is M/IO bar? It is pin 28. Data is taken from memory or IO. M/IO bar is 1, it indicates it is IO operation, and M/IO bar is 0, it indicates memory operation. DT by R, that is data transmit/receive. It stands for data transmit/receive signal and is available at pin 27. It decides the direction of data flow through the transceiver. When it is high, data is transmitted out and vice versa. Done. Data enable. It stands for data enable. It is used to enable transceiver 8286. The transceiver is a device used to separate data from address/data bus. And what is INTA? This is interrupt acknowledgement signal. And when microprocessor receives the signal, it acknowledges the interrupt. Okay. So that's all for this session. More in the next session. Thank you. Thanks a lot and I wish you all the best.